In today's lecture, we will study systems of linear equations. Okay, let's start with the definition. The general m times n system of linear equations is of the form, so we have m equations and n variables, so a11 x1 plus a12 x2 plus a1 and xn is equal to b1. So we have an first equation where there are n unknowns x1, xn with constant coefficients. So all these aij's are constant coefficients. And so these are equal to b1, b2, bm. So if all b1, b2, bm are 0, then the system is called homogeneous system. Otherwise, it is called non-homogeneous system. And so why we studied matrices? Because we want to write this system in terms of matrices. So we will write it, this system as, okay, maybe I will make it smaller. So we will write this system in terms of matrices. So the matrix A times x. So this matrix A is the coefficients, matrix of coefficients. So A and we have x here, and it is equal to the matrix B. So we have AX is equal to B. So where A is an m by n matrix. So this is n by 1 matrix, and when we multiply we will get n by 1 matrix, right? So this is n by 1 matrix and this is n by 1 matrix. So if for multiplication, remember we should have, so these should be equal, right, to multiply matrices. And we have this situation in our case. So we have AX is equal to B. And whenever we have such a system, so we have another matrix, so A sharp. So what we are going to do is we write the coefficients. So A12, A1n, A21, A22, A2n, and AM2, AMN. So we write the coefficient matrix, and next to it we will write B1, B2, Bm. So this matrix is called the augmented matrix of the system. So in the exam I also ask find the augmented matrix of the system usually. Okay, so what I mean is, so for example, given a system of linear equations okay, let's say we have x1 plus 2x2 plus 9x3 minus x4 is equal to 1. So we have 4 unknowns, x1, x2, x3 plus 7x3 plus 4x4 is equal to 2, and x1 plus 3, x2 plus 5, x3 is equal to 5. Given this system, write the augmented matrix. Okay, we will write it. So A sharp is, we write the coefficients, right? So we for the first equation, so for this one, for the first equation, we have the coefficients 1, x, 2 is 2, 9, and minus 1. So this column is for x1, and this is for x2, and this column is for x3, and the last column is for x4. So for what is the coefficient of x1 in the second one? 2. What about x2? The coefficient of x2 is minus 3. x3 is 7, and the coefficient of x4 is 4, and 1, 3, 5. What about the coefficient of x4? It is 0 here, and we write b1, b2, b3 in just right next to it. So this is the augmented matrix of the system. Okay, so what else? Advantage of the system. So how we solve the system? So we have the Gaussian elimination method. So to solve a system of linear equations, so we follow the following process. So we use the following, or say we use the following process. Okay, in step 1, so what we are going to do is, okay, we always find the augmented matrix. A sharp, and the second one is find the reduced row echelon form of the matrix. Find the reduced, not necessarily reduced, but row echelon form also works. Matrix A sharp, so the augmented matrix. And this process is called Gaussian elimination. So this process is called Gaussian elimination. Great. Okay, let's do a lot of examples, because we will study in each case, like we will have a system that there is a unique solution. We have a system no solution exists, and we will have a system that we will have infinitely many solutions. So we will learn all of them. Okay. Okay, the question is find the solution set of the following system. So we have 3x1 minus 2x2 plus 2x3 is equal to 9. x1 minus 2x2 plus x3 is equal to 5. And 2x1 minus x2 minus 2x3 is equal to minus 1. Okay, in first step we said that we will find the augmented matrix first, and then we will find the row echelon form of the matrix. So what is the augmented matrix of the system? So we write coefficient 2 minus 2, 2, 9, 1 minus 2, 1, 5, 2 minus 1 minus 2, we will have minus 1. Okay, then how we find the row echelon form of this matrix? So if you remember, what we are going to do is we always arrange this leading term to be 1. So what you can do is you can divide by 3, but we will have minus 2 over 3 here, so we don't want to deal with the rationals. The other thing we can do is, so we have already 1 here, we can change so we can change the rows, and then so what we are going to do is, okay, let's start finding row reduced echelon form of this matrix. Okay, first thing we are going to do is we will change R1 and R2. So we will write R2 to R1. So 1 minus 2, 1. But don't forget to change the other side. So whatever we are going to do is we do it in the whole matrix. Okay, great. Now we have 1 here and we will arrange these to be 0. So how we can do it? So we can multiply minus R1 and we can add to R2 and write to R2 minus 2R1 plus R3. So these operations will make these ones to be 0. So they will be 0. Okay, I hope I will not do anything wrong. Okay, we multiply first row with minus 3 and add to the second row. Minus 3 times minus 2, 6, minus 2, we have minus 4. Minus 3 times 1, so we have minus 3 plus 2, minus 1. Minus 3 times 5, minus 15 plus 9. 15 plus 9, we have minus 6. Okay, what about third row? So we multiply first row with minus 2 plus 2, minus 2, 4 minus 1. So we have 3, minus 2, we have minus 4. Minus 2 times 5, minus 2 times 5, minus 10, minus 1, we will have minus 11. Great. Great, then what we are going to do is okay, what we are going to do is now we will arrange, we should arrange this to be 1. How we can do that? So what we are going to do is we will arrange this to be 1. But if you see that if we subtract R2 from R3 from R2, so the row minus R3, we will get that one to be 1, right? 1 minus 2, 1. 5, 0, so we will multiply, we will subtract the third row from the first row, so we have 1 here, minus 4, 4 minus 1, so we have 3 here, 11 minus 6, we have 5 here. Great. 0, 3 minus 4 minus 11, and now we will arrange this 3 to be 0. So how we can do that? We can minus 3 R2 plus R3, we will write it to R3, row 3, 1 minus 2, 1, 5, 0, 1, 3, 5, 0, and we will have 0 here, minus 3 R2. Minus 3 times 3, minus 9, minus 4, minus 13, right? So we have minus 13, minus, okay, minus 3 times 5, minus 15, minus 11, we have minus 26. Great. And then what we are going to do is, we are lucky. So how we will make this to be 1? We will just multiply with minus 1 over 13, and we will write it to R3, the row 3. So we have 1 minus 2, 1, 5, 0, 1, 3 to be 5, 0, 0, 1 is equal to 2. So now we have a simpler system, and we can just read it from here, right? 0 times x1 plus 0 times x2 plus x3 is equal to 2, right? So we can just read this new system. X2 plus 3, x3 is equal to 5, and x1 minus 2x2 plus x3 is also again 5. And we can just solve it, right? Using this x3 is 2. So we have 3 times 2 is equal to 5. So we can find x2 here, which is minus 1. And then we will substitute x1 and x3 to this last one. And we will find x1 also minus 1 plus x3 is equal to 2 is equal to 5 again. So what is x1? If you compute x1 is equal to 1, right? So we find x1 to be 1, x2 is minus 1, and x3 is equal to 2, sorry. So this system, in this case, has a unique solution. What is it? x1, x2, x3, and we find it x1 to be 1, minus 1, and 2. So the solution set is, so we have this solution set, 1, minus 1, and 2. So we can write it like this. Okay, we will continue to solve examples in the next